Greetings, M Squared here. Today we're going to talk about our final learning target for topic 6 in our chapter 6 of our exponential functions. Our last learning target is to be able to use exponential functions to solve problems and make predictions. So we are going to talk about word problems today, or applications to the exponential function. Real quick reminder, exponential growth goes up from left to right, decay goes down from left to right. B is greater than 1, it's growth. If our B is less than 1 but greater than 0, it's a decay model. We're going to have a little twist on the model today. Before, we just had one number in here, but notice what's happening is we know B can't be 1, but B plus R is how we're going to do our growth model. So we know it has to be bigger than 1. That's why we're adding something, right? When B is bigger than 1, so it's 1 plus something, that's going to be our exponential growth model. And when we're subtracting something from 1, that's going to be our decay model. So that R is pretty important when we talk about word problems, because R is standing for our rate. The rate that something's growing or the rate that something's decaying. So we need to understand how to find that R when there's a number there, because it's not going to say 1 plus. There's going to be a number there, and we have to extract the R from it. That's one of your goals today. So the rate that you see here is going to be a decimal, but we can change it to a percent, and sometimes you have to. So we're going to talk about the difference between the decimal rate and the percent. The decimal is what we use in our calculations, but if you went to the store or you were talking to someone about the growth rate, you might say, you know, it's growing at 2%. You might use that terminology instead of 0.02. So we're going to talk about the difference there. Hopefully you remember a little bit about percents. So to find the growth rate in a growth model, we actually have to subtract 1 from that number, so we just have the R. So right now it's 1 plus R, but if we want to find the R, we subtract 1 and we're left with just the R. To find our R in a decay model, we're going to subtract the number, this whole number in the parentheses, from 1. So see, there's a difference. We're subtracting 1 or we're subtracting from 1. And we'll talk about that in a second. Here's our example. If I have a 1.3, this is the easiest one to see, right? Because it's 1 plus 0.3. You might not even have to subtract 1 with your calculator, but if you might have to, but you can usually see the growth one. If it's bigger than 1, we say, oh, that's the rate right there, 0.3. And how do you write 0.3 as a percent? Well, percent means per 100, so we'd multiply by 100, and we'd get 30. So that means our growth rate is 30%. That's the percentage of it. You could also say 0.3. Depends on how they're asking the question, so you have to know how they're asking it. If they want a percent, you have to say 30. Whereas the decay one's not as easy to see, because you have to subtract this number from 1. So it's how much do you need to get to 1 is what our rate is going to be here. So 1 minus that number is 0.24, which means it's 24%. So keep that in mind, because part of your assignment, you're just going to have to find the rate of growth or the decay. You're going to have to know whether it is a rate of growth or decay. And that's all about B. So let me just turn my page here. So this little chart is just about, is it growth or decay, and what's the rate? So I'm just going to put a G for growth and a D for decay. So we're just going to go right through and do that, and then we'll come back and get some of them. We won't do all of them, but we'll do some of the actual rates. That is bigger than 1. If B is bigger than 1, it's a growth. Okay? If B is smaller than 1, but greater than 0, so if this is between 0 and 1, which it is, see, 0 point something, then that's a decay model. Bigger than 1, growth. Bigger than 1, growth. Bigger than 1, growth. Between 0 and 1, decay. So now I'm going to go back and I'm going to help you find out the actual rate as a percent. So I'm just going to try this one. We'll do a decay one first. So I always want to know how much do I have to add to that to get to 1. Because remember, I have to take that number away from 1 to find out my decay rate. So that would be 0.06. It's kind of like 94 cents and 6 cents gets me $1. So what do I have to add to get to 1? Or you take your calculator and say 1 minus 0.94. Well, now that is okay, but if they're asking for the percent, I have to multiply it by 100. Shortcut to multiplying by 100 is just to move the decimal over twice. to the right. And so I know that this is a decay rate. Decay rate, I'll squeeze it in there, of 6%. So it's decaying at 6%. I will do this one. Oh, look, I put two the same. Look at that. I just noticed that. So this one, I say, what do I have to add? So I'd subtract 1 from that, and that's 0.2. And if I multiply that by 100, that's a 20% growth rate. Growth rate. So that is my rate of growth. I'm going to do this one to show you. That's 2.5. If I subtract 1 from that, I actually get 1.5. And then I have to multiply it by 100, which gets me 150%. So it's growing at 150%. And then finally, this one, and I'll show you how to do that on your calculator, just so you know, because it's just about adding or subtracting from 1. So I would say 1, sorry, I was going to do another decay one for you. I was going to do this one. 1 minus 0.29. And that's 71.71. And if I multiply that by 100, then I get 71% decay, rate of decay. All right, so that's how you tell whether it's growth or decay model, and that's how you tell what the rate is. And you'll have to do that for part of your homework. Now, we're gonna go over these in class, but I wanted to make sure you understand some of the vocabulary that you're gonna see when you have a word problem, but also some people forget how to round. So sometimes you need to know how to round when you're doing these equations, when you're actually figuring things out. So I wanted to let you know that if I have 1.378, and I'm asked, let's say that I was talking about money, and I was asked to round to the nearest cent, because that's cents, then I would look at the number right here, and that's an 8, which means I'm closer to, if I cover that up, I'm closer to 80 than I am to 70. So it's always a choice between that. Do I leave it 7, or do I go up to 8? And since this is an 8, I go up. So you only round up if this number to the right is a 5, 6, 7, 8, or 9. So then that would be approximately equal to 1.38. Just a little reminder. If this had been a 4, I would just said 0.37. Some of you remember that, but some of you might not. So just a little refresher. Okay, so on this page, I'm showing you, and these are in your notes, this is how you do it. And then we're going to go through examples. So we're going to do some word problems, but this is what I will be referring to when I'm talking about what you do, what all these things are, okay? So A is the initial amount, X is your time in years. And we're going to plug things into our formula, this formula. So you need to know those formulas. That's what we're using. So question number 1 says, a town has a population of 7,000. Population growth and decay is we use exponential functions for population growth. A town has a population of 7,000 and grows at a rate of 4% per year. Okay, there's our, every year it's growing at 4%. This is our rate, that's our R. This is our initial amount, that's going to be our A. So anytime you see an initial amount, you want to know that that's A. Anytime you see a percent or a rate grows at certain every year, we know that that's our rate. What will the population be after 13 years? There's our X. Right? Our time is going to be our X. So we have a 4% that we have to change back to a decimal. When we changed it to from a decimal to a percent, we multiplied by 100. So to change back from a percent to a decimal, we're going to divide by 100. Our initial amount and our 13 years. So this is how we write our equation. It's f of x equals the initial amount. So that's our 7,000. Then we put our b in here, and we put our x there. But remember, our b was 1 plus our rate as a decimal. So that's 1 plus this. So we'd say 1.04 because we're adding the rate. This is our equation. And if I want to know what happens after 13 years, how many people there will be, I will put this into my calculator. I'm going to show you how to do that. And this becomes 13. So we'll take this out for our specific problem, right? We could do it for any amount of years, and we're going to put that in our calculator. So we're going to say 7,000. We're going to use our parentheses, and we're going to say, what was our rate? 1.04. And then we're going to take that to the power of 13, and that will tell us what happens after 13 years. You've got to use that little arrow. It's called a caret. Sometimes calculators have a y to the x key. You can also use that. So I'm going to put 13 in and it's going to tell me. Please be logical when you look at your calculator. If you got a number like 100, you know you're wrong because it's supposed to grow. It started at 7,000. So make sure you think about the number you get. Sometimes you can put something wrong in your calculator. You might forget the little arrow. You might have multiplied instead. So pay attention to what's happening. This looks like 11,655, or 56 if we round to the nearest person. So we're going to say that that is how many people. So we're going to have 11,656 people. Now, I always want you to clarify with a word what you're talking about. If you're talking about apples, then put apples, but don't just put a number. If you're talking about dollars, you can put a dollar sign, but make sure you are aware of what you're talking about because it's asking, what will the population be? It's going to be 11,656, but we're talking about people. Okay, that's supposed to say car. It says a new car. A new car is purchased for $16,200. The value of the car, oh my, depreciates at 14.25% per year. Okay, there's our depreciation rate. What will the value of the car, wow, be to the nearest cent after 6 years? I didn't know I made so many mistakes. All right, so let's think about this. What's our initial amount? Our initial amount is how much the car was worth. Okay, what is the rate of depreciation? Well, I have to divide by 100, so that's going to move the decimal place. Here's my rate of depreciation. My time is in 6 years. But remember, the B is what I get when I subtract 1.425 away from 1. So I'm going to do that real quick, just so I know my rate. So 1 minus 1.425. Sorry, I did not say minus. Minus let's see, 0.8575. So now I know my B is 0.8575. Now I'm ready to write my equation. So f of x is equal to the initial amount. And then here it's 1 minus the rate, which I already found. It's 0.8575 to the 6th power. Now that's where my x would go, but they told me how many years it would be. So I put the 6 right there. And now I just put it in my calculator. So 16,200, must use parentheses here. 0.8575 is my rate of decay, and I'm going to take it to the power of 6. And we would expect our car to depreciate, so our car should be less, a lot less than it used to be. So you can see that it's, and this is money, it's worth $6,440. And I always like to round to the nearest cent with money. So I'm going to say 50. That's a 0, that's a 3, so I don't round up. I keep it the same. But I want to put the 0 there because I'm talking about money. Okay, let's try a couple more, and then you're off to the races on your own. $6,700 is placed in a savings account with an annual interest rate of 8.25%. How much will be in the account after 28 years to the nearest cent? What is the rate as a decimal? Okay, it was 8.25, so I'm going to divide by 100, and I'm going to get 0.0825. What was the initial amount invested? $6,700. How much time is this going to sit in that account and grow? 28 years. And now I'm going to write my equation. I don't have to use f of x. You can say y if you want. So y equals the initial amount times 1 plus, so that the plus is easy because you just tack that on in decimal, and then to the 28 years. 28 years, that's kind of a long time, right? Longer than you've been alive. So here we go, 6,700, and then in parentheses, you got to use parentheses and the little caret, 1.0825. We're going to take it to the power of 28 and see how much money is in there after 28 years. All right, it looks like 61,000. Not bad, right? $61,667.47. It's money, so I'm going to the hundredths place. Okay, let's do our last decay problem. Then you're off on your own. Here we go. An element with a mass of 490 grams decays at 28.6% per minute. Whoa, that's pretty fast. How much of this element is remaining after 16 minutes to the nearest tenth of a gram? All right, what was our initial amount? 490 grams. What's our rate? Our rate as a decimal would be 0.286. How much time is going to pass? 16 minutes. Now remember, since it says per minute here and we have minutes here, we're good to go. If that was a different amount, we'd have to make sure that that was the same amount, and we'd have to do some calculations for that. You shouldn't have to at this level. It's going to be pretty easy. When you get to chemistry, yeah, you'll probably do stuff like that. We've got to change now our B. We've got to find our B. Remember, our B is 1 minus the rate. 1 minus 0.286. So we're going to say 1 minus 0.286 to find our rate. I'm sorry, to find our B. 0.714. So 0.714. So that's what we're going to use to write our equation. So what is the initial amount? 490 grams. And then our rate of decay is our right here. Well, this is what's left, actually, I should say. This is what's left after every minute, and we're going to go 16 minutes. So let's put that in our calculator. 490 times 0.714 to the power of 16. Did I get that all? Yes, I think so. And there's going to be 2.2 grams. Now, it didn't say what to round to. Yes, it did. It said nearest tenths of a gram. So I'm going to go out to 1 decimal place. That's a 3, so I keep it the same. So 2.2 grams. You can see it's almost gone. So they kind of use this system. When you take medicine and you put it in your body, or even caffeine, actually, after a certain number of time, it's like half gone and then half gone. That's how they tell you you're going to need more pain medicine, or you're going to need more coffee to stay awake, that kind of thing. This happens anytime you take medicine in your body. It kind of decays it at a certain rate, and it depends on what it is. But some elements decay as well. So keep in mind you have 2 different models for your growth and decay, and it's really tricky because here you're adding R and here you're subtracting R. So good luck with those word problems. M squared, signing out.